So here's the rule of thumb of how you can pick the learning the step size eta when you're doing gradient descent. Unfortunately, there is really there's some theory behind things that you might want to do, but it's kind of hard to apply those in practice. Here's the most practical thing that you do. You try several values of the parameter exponentially spaced between each other, like 10 to the minus 4 to 10 to the minus 6, that's kind of exponentially spaced. And the goal is plot the learning curves to find an eta that is too small. So the curve is moving too slowly, too slowly, too slowly. And then you find an eta that is too large. It's wild oscillations and it's diverging even. And now we have a big value and a small value. And then you can try values in between. Again, exponentially spaced. And pick one that leads to the best training likelihood. And that's how you do it. Pretty simple heuristic, but it's basically something that you'll have to do if you're implementing this from scratch. Now note that so far we've looked at only fixed step size. Every iteration we use the same step size, like 10 to the minus 5 everywhere. Here's an advanced step. In theory and often in practice, it's good to pick step sizes that decrease over the iterations. So in the beginning, you take really big steps because you're very far away from the optimum. But towards the end, you take much smaller steps to just hone in to that perfect value. So if you imagine you take the contour plots, in the beginning, you're taking big steps like this. But to be able to get to the optimum, you take very little steps towards the end. And that's how you kind of hone in to the optimum here, W hat. So what does that equation for the step size look like? There are various ways of defining them. I'm just going to give you one pretty practical example, which often works well. So you pick a step size that depends on the iteration. So iteration t, you're going to use eta t. And the way you're going to write it is by writing eta 0, some constant that you tune using the same kinds of ideas that I described above. You find the minimum, the maximum, the range in between, and then you divide that by the iteration number t. That's it. So iteration 1, use eta 0. Iteration 2, you use eta 0 over 2. Iteration 3, eta 0 over 3, over 4, over 5, and so on. And that way, the step size keeps getting smaller and smaller and smaller. So this is an advanced step. For the applications that we're going to discuss in this module, constant step size will do just fine for you. But for kind of more advanced settings, you might use a decreasing step size.